An inverse function reverses the input and output of the original function. First, write the function using y in place of f of x. Then we switch x and y because we want to switch the input and output. This gives us x equals negative cube root of 4y. Now solve for y. Since y is inside a cube root, we get rid of the cube root by cubing both sides. This gives us x cubed equals, since raising a cube root to the third power cancels out the radical, we get negative 4y. Recall that the negative sign remains when it's raised to an odd power. To isolate y, we divide both sides by negative 4. Now that we've solved for y, we replace it with f inverse of x. We get f inverse of x equals negative x cubed over 4. Let's try another one. Write the inverse function of f of x equals the square root of x minus 2. This is a square root function which is translated 2 units to the right. Just like in the previous problem, we replace f of x with y. Then switch the roles of x and y. This way, the input becomes the output, and the output becomes the input. Now solve for y. By first squaring both sides, we get x squared equals y minus 2. Adding 2 to both sides, we get y equals x squared plus 2. Now, before we write it as the inverse function, let's check the domain. Note that the domain of the original function consists of all real numbers greater than or equal to 2, because the expression inside the square root cannot be a negative number. And the range is all real numbers greater than or equal to 0, because the square root of a number cannot be negative. When finding the inverse of a function, the domain and range swap. Therefore, f inverse of x equals x squared plus 2 for x greater than or equal to 0. You can verify this on the graph. The inverse function is a quadratic function translated 2 units up for x is greater than or equal to 0. This gives us half of a parabola, and the inverse functions are reflections over the line y equals x. Use composition to determine whether f and g are inverse functions. Inverse functions undo each other, which means when we take the f of g or g of f, you get the input value x as the output. You must check both compositions because one direction might work while the other fails. Let's check f of g first. The rule for g of x becomes the input, and wherever there is x in f of x, we replace it with the expression. We get 2 times the expression, half of x minus 5 halves plus 5. Let's simplify by distributing the 2, giving us x minus 5. Then add 5. The negative 5 and positive 5 cancel each other out, leaving us with just x. So that worked for f of g. Now let's check g of f and see if it also gives us x. The rule for f of x becomes the input for g of x. Wherever there is x in g of x, replace it with 2x plus 5. We get half of the quantity 2x plus 5 minus 5 halves. Distribute 1 half. We get x plus 5 halves, then bring down minus 5 halves, which cancel out the other 5 halves. So we get x. Since both f of g and g of f of x are equal to x, the functions f and g are inverse functions.